Hello everybody, welcome back to my channel. If you can call a method directly, why do delegate even exist? That's the question almost every C# developer has at some point. Many C# tutorials jump into delegate syntax, but that's the wrong place to start because you need to understand what problem delegate were invented to solve. Delegate were not invented to call a method. They were invented to delay the decision of which method should be called. By the end of this video, you will learn delegate, multicast delegate, action, func, and predicate expression, and you will learn also lambda expression and anonymous method. It's so important. At first, you have to know what problem delegate solve, and after that, we will create a solution step by step. Let's begin. Before we write a single line of code, I have a simple question. If we can't call a method directly, why do delegate even exist? For example, here I have a SMS method. I easily write the method and call it. Simple, clear, and done. Why would anyone introduce delegate instead of just calling the method directly? And that's the question we are going to answer in this big video. Because the delegate were not created to make the method calls easier. They created to solve another problem. Here, for example, you have a reusable notification library, and that application are using by 100 different applications. One of them want to send email, one of them want to call an external API, and one of them want to use it as a logger. In situation like this, that the application doesn't know anything about the behavior, and it doesn't know what it will need in the future. And that's the question. If in situation like this, if the application make the decision already, is completely wrong. In situation like this, your code shouldn't make decision. The caller should make which behavior should execute, and that's the where the delegate comes in. A delegate let us to pass the behavior, and that's so important. For example, here I have a delegate that it send notify. For example, here I want to I am the caller. For example, here I want to pass an SMS behavior. Another time I want to pass an API behavior, and that's the power of delegate. Delegate is not just a make, for example, a call a method. A delegate let us to pass a behavior instead of sending it a static or, for example, call a method. And that's completely wrong. If you know, if you step out that the task of delegate is calling a method. A delegate let us to passing a behavior. Now it's time to know what is the syntax of a delegate, how we can create a delegate, and how we can pass a method to that delegate. Let's do it. Now, it's time to build a delegate from scratch. If you want to create a scratch, you can create it in for example, into your class, or you can create a delegate out of your class. But if I want to suggest you don't, for example, create a class into another class, maybe in some special situation like nested class. And it's not because the delegate is a type and is a reference type like a class. It's better to create a delegate out of a class. For example, here, if you want to create and delegate, the first item is the access modifier. For example, I say the access modifier I want to use is public. After that, you have to use a special keyword is delegate. After the special keyword is the return type. For example, what is the return type of your delegate? For example, I'm saying void. Now it's time to give a name to your delegate. For example, I say I want to call it send notify. Here, you can to pass a parameter. For example, here I want to use a parameter and say call it item. Every delegate has defined a method signature. What is a method signature? A method signature has three different parts. The first part is the return type. For example, the return type of my delegate is void. After that, is the number of your parameter. Here I have only one parameter. And the last one is the type of your parameter. The type of my parameter is a string. Every method that has the same method signature as my delegate can pass to this delegate. Okay, now it's time to create an instance of my delegate. For example, here I say send notify and I want to call it notify. Now, which type of method I can pass to this delegate? I told you every method that has the same signature method I can pass to this delegate. For example, here I have a send method. The return type is void, but it doesn't have a one parameter of type string. For this reason, I cannot pass it to my delegate. If I pass it to my delegate, I will get a red underline method error. Sorry, because it doesn't have the same method signature with my delegate. But the second one is send SMS. It had the return type is void. It had one parameter of type string. Now I can pass it to my delegate. Now it's okay. Okay. Now, maybe now you are thinking that why not just calling the method directly? Okay, wait. For example, suppose if you call a method, for example, send SMS directly. I told you in delegate, or I told you, for example, you have a reusable notification library that the application shouldn't make the decision. The caller should make decision and which behavior should be called. For example, here I am the caller and I'm saying, hey, I want to pass the behavior of, for example, SMS. Oh, now, for example, another day you are saying, hey, I want to send an email. I want to call an API. Now, you can, without changing the caller and any code here, you are just changing the behavior. For example, I am saying, I want to change the behavior. Which behavior? Sending email. Okay, the sending email is here. It had the same signature with my delegate. And that's the power of delegate, is let us to pass the behavior. Okay, now it's time to know how we can run a delegate into my program. There are two ways. First one is you just type, for example, notified and call a method is invoke. Okay, and here I have to pass a method. For example, I say, hey, I am sending email. Now, if I run the program, I will say, hey, I am sending the email. That's the behavior of email. Okay. Now, another way is just type your delegate and open and close the parenthesis and just pass your parameter, something like this. And now here I have two different ways. First one is just call invoke, and another one is just write the name of your delegate and run the program. But if I want to suggest you which way you have to use, I will say, hey, use this way, because let me remove this one. When you are calling the delegate in this way, the CLR will convert it to the invoke method in the back, and you cannot see anything, and we call it as a sugar syntax. Okay, let me change the delegate method signature. For example, hey, I have another method here. Here is the return type is int. It has two, for example, different parameter. Here I'm come here and say, hey, I want to have a delegate with the return type of int. I want to have two input. First one is, for example, item 1, and the second one is int, and it's item 2. Here, then what is the method signature? The method signature is the return type of type int, and I have two parameters. The first one is int, and the second one is int. Here, I got a red underline because the send email doesn't have the same method signature with my delegate. For example, here I have a method, it's called, for example, the name is add. It has the same method signature with my delegate. It has a return type of int. It has two parameters, and the first one is type is int, and the second one is int. I can pass it to my delegate, for example, add. Did you see? And that's the power of delegate. You don't need to change the code. You are just passing the behavior. If I do something like this, you cannot see anything because I have to store the result. For example, I say int result. Let's say do something like this, and just, for example, say result. If I run the program, you will see the 30 in the output. Okay, now maybe you are thinking, hey, I'm just passing one method to my delegate now. It's time to know what is a multicast delegate, and that's the power of delegate. We have an item is multicast delegate. You can pass many items, many methods to your delegate. Now it's time to know what is a multicast delegate. Let's do it. Now it's time to talk about a feature that we call it multicast delegate. There is a question. Delegate only reference to one method, or we can reference to many different methods. Yes, the answer is yes. We can point to many different methods that have the same signature method as my delegate. For example, here I have created a delegate. Is the return type is int, and it has two parameters. The first one is int type, and the second one type is int. For example, here I have three different methods. First one is add. You just do a some basic math operation, and the second one is division, and the return type is int, and it has two parameters. And the last one is multiply action. Here I want to pass these three different methods to my delegate. How I can do it? For example, here let me remove this one. If you want to pass another item to your delegate method as a multicast delegate, you have to use two items, plus and equal sign. Here you are saying, hey, I want to add another method to my delegate, and that's the reason the delegate are so useful for event. They are so useful for notification. They are so useful for event, and that's the power of delegate. Here saying, for example, I want to pass another method is division. Here I have another method division. That now we are using the multicast delegate feature. For example, I want to add another method. It's plus equal and say multiply. What did I say? I'm sorry. Multiply. And just type it here. Okay. And let me change it to something like this, because I want to do division. Here, if you think about it, now you are saying, hey, I have point to three different methods, and they execute in order. The first one is add, the second one is division, and the last one is multiply. But what is the result of these three different methods? For example, the first one add, for example, 20 plus, for example, 10, the output is 30. The second one, the 20 divided by 10, the answer is 2. And the last one, 20 multiply, for example, the 20 times to 10, the answer is 200. But which one is the output? Let me see. The output is 200. That's a very important point, and that's very important item that you have to understand. When you are using a delegate with the return type that is not point, for example, it's something like int, it's something like a string, the output is the output of your last method. It's so important. Here, my last item and my last method is multiply, and the output of multiply method is 200, and the output of my multicast delegate is 200. It's so important. But there is a question. If one of these methods crash, for example, suppose you are three different methods. One of them is calling an API. Another one is logging some of items into an external file. And the last one is, for example, calling some data from database into the application. For example, the first item is calling an API. Okay, it's for example, it's run and it's okay. It's time to run the second method. For example, it's logging. But if, for example, something bad happened to the application and the second method crashed, what happened? In situation like this, the last one, for example, here I have three different methods, and the last one is the third item. And if the second one crashed, the last one won't run anyway. That's the time, and that you have to know. For example, in a situation like this, Multicast Delegate has a special method is GetInvocationList. And now it's time to know how we can solve a situation like this and don't let for example, the delegate to crash, and just manage it. Now it's time to know the power of delegate, and it's time to know what is a invoke dynamic method, and it's time to know what is a get invocation list. Let's do it. Now it's time to know how we can manage if we crash and if we got some exception when we are using multicast delegate. Here you have to iterate over all of your delegate. Here we want to use for each and say, now here we want to call it handler. Here my delegate is notify, and here I have to call a method is get invocation list. And here you have to create a try catch. I will explain to you later. Don't worry. Here I just, for example, here I'm logging the exception. For example, here I am logging the exception. And here is use string interpolation. You want to say something like this. That's the message. Now, here we want to use a special method. I told you if you want to run a delegate, you have two ways: invoke and just type the name of your delegate. Here, if I type invoke, now here I don't have invoke. I have to use another method. It's dynamic invoke. What's the duty and what's the task of dynamic invoke? Wait. First of all, I have to say what's the return type of GetInvocationList. When you are typing GetInvocationList, if you pay attention here, the return type of the GetInvocationList is an array of your delegate, not all of your delegate, this delegate here, the base delegate, because every, for example, the get invocation list designed to work with any different data, with different type delegate, not just something that I'm using in this example. For this reason, that's the array is for example here I have three different methods, and in this array it has three different methods, but it doesn't know the exactly return type. And if for this reason I'm using the dynamic invoke. What is the task of dynamic invoke? When we are using the dynamic invoke, we are using, hey compiler, I don't know what is the exactly type of my delegate, and that's the reason, hey, you figure it out when you are run the program in the runtime, and that's the reason the dynamic invoke is slower than you are, for example, calling a delegate directly, and that's one trade-off. That's so important because it's using some reflection internally, and the speed is slower than you are calling the method directly. But it's so important to know. Every time you shouldn't use in dynamic invoke because it has some bad effect. And for this reason, what is some special situation that you have to manage your delegate in situation like this, that you want to manage over all of your delegate, use GetInvocationList, and after that dynamic invoke. And when you are using dynamic invoke, you are saying to the compiler, hey, I don't know what data type and what is the return type these three different methods are using. Figure it out when at the runtime. And for this reason, it's slower than the you are using or calling it delegate directly, and it's not type safety. It's so important to know. Now, in the next part, we should talk about the action, func, and predicate, and there are some expressions that let us to use this very basic delegate in my code. But why? When we can create some delegate like this, the Microsoft introduced action and func in the C# version 3. Now let's do it. In the next part, we are talking about action, func, predicate, anonymous method, the Lambda expression, and what's the relationship between the delegate and the event. Okay, goodbye. Don't forget to subscribe the channel and like the video.